Most motors don't fail because they're weak, they fail because they're started the wrong way. A VFD control panel changes the game by managing torque, reducing inrush current, and protecting equipment from unnecessary stress rather than just turning a motor on or off. When these panels are engineered properly, you'll see a significant drop in energy consumption in mechanical wear, leading to increased motor life, smoother processes, and fewer breakdowns. Real engineering discipline shows in the technical details like heat management, cable shielding, harmonic considerations, and proper parameter tuning, because a VFD is only as good as the panel built around it. Smooth acceleration isn't just about motors, it's about discipline in design. When a VFD panel is engineered properly, energy consumption drops. Mechanical wear reduces, motor life increases, processes become smoother, breakdowns decreases. So let's focus on avoiding common mistakes to ensure long-term reliability and finally stop replacing motors. If you work with motors, drives, or process control, what's the most common mistake you see in VFD panels?